This is a 433 megahertz controlled mains switch socket. Basically, mains plug on the back, mains socket on the front, and you control it with a remote control. This device here. Home, easy, remote control. I think the remote control is an HE302B. What's he got here is neutral coming here, common neutral coming in from the mall, going through a 100 ohm resistor, through a 220 nan capacitor, an X2 capacitor, capacitive dropper, got a 2.2 meg resistor across that cap, a bleed resistor, 22000, yes, 2.2 meg, and that goes somewhere else, not sure whether, probably goes into that Zener diode there. Is that a Zener diode? Z. I'll find the component designator on that diode. This one. ZD. Yeah, it's a Zener diode, I think, so that's basically going into the bottom of that Zener diode. The anode, which is basically Zener, excuse me, Zener diodes are reverse biased, so that will be going to the anode. The feed live, which is the rivet in the middle there, inside that gold area. This just above my thumb, there's a circle. That is the feed live coming from the wall for the mains on the stripy white lead. That's going onto the board, but I can't see where we've got a thermistor here, I think. A fuse, sorry, that's a fuse there. That black package there, strapped onto that relay with a cable tie and gunked on, is a fuse. 2 amps, 250 volts, so that's nice to see that. Got a 433 megahertz antenna here. This metal loop. Pairing switch here. The status LED. Basic construction. On the underside of the board is all the 433 megahertz receiver circuitry, which I haven't got to yet. I need to work out how to get this PCB out without damaging it. So I think I have to remove these screws on this socket first. But on this screw here and this screw here will have to be removed first, I think. But I can access the underside of the PCB to see what's going on. Markings. What does it say? 010 OL, that's Oscar Lima Yankee Charlie Romeo 3500-000. Could be 0, could be an O, probably a 0. Song Chuan relay. Never heard of you, mate. 17 amps at 250 AC, 20 amps at 125 AC. Actuation, the coil actuation is 20 volts, 24 volts DC. Single pole, single throw by the looks of it, normally open. Makes sense. And that's about all she wrote for the moment. There's more underneath here. What's underneath this capacitor here? Let's see what's underneath there, shall we? Leave that up a bit on my thumb. Just leaving it up there. Sorry about the camera angles here. Oh, here we go. There's more under here. Where's the capacitor? There we go. There's some more diodes under there. A bridge rectifier by all intents and purposes, by the looks of it. To all intents and purposes. yeah, 4 diodes, bridge rectifier, and the Zener, as we saw before. So basically there's a capacitive dropper. There's a 100 ohm inrush resistor there, the pink one here, feeding into a 220 nan cap with a 2.2 meg bleed resistor across it. I presume that's going into the bridge rectifier, then when the bridge rectifier output is going straight across that Zener diode, that pink cylinder. Just, can you see that? Where's my finger? Where's my finger gone? It's on your hand, mate. Under the cap, under that yellow block, there's a little red, orange cylinder. That's that Zener diode, I think. So, at the moment, that's as far as I got reverse engineering this device. So, I'll do a part 2 if there is one. And it's the Home Easy HE302B for Bravo. See ya.